Working at heights demands skill, focus, and experience. But even the best preparation can't eliminate every risk. A single misstep, an unseen opening, a momentary distraction, equipment issues, or changing weather can quickly turn a routine task into a serious incident. That's where fall protection comes in. It's your last line of defense when the unexpected happens. This training is about protecting lives, preventing life-altering injuries, and making sure every employee goes home safe at the end of the day. Fall protection supports even the most competent workers by backing up their experience with reliable systems and safe practices. By using proper fall protection every time, you help build a strong safety culture, one that recognizes accidents can happen to anyone and proves that your safety always comes first. After completing this course, you will be able to identify common fall hazards, recall what to do if you encounter unsafe conditions, recognize the types of equipment and methods that provide fall protection, identify the components of a personal fall protection system, recognize the importance of inspecting fall protection equipment, and recall important information about fall rescue plans. Your company has the responsibility to protect you from fall hazards. A good precautionary measure is to use fall protection anytime you are working on an unprotected or elevated work surface from which you could fall. Fall protection is generally required whenever you are working 4 feet above the ground or next lower level, when working in general industry, and 6 feet above the ground or next lower level when working in construction. If you are unsure about using fall protection on your worksite, ask your manager, supervisor, or a fall protection competent person for guidance, as they will be knowledgeable about any site-specific rules in place. Most workers probably don't think they will ever fall. They may have no fear or respect of heights and fall hazards, or they may not be paying attention to where they are, since it may be a job that they have done successfully without an incident 1,000 times. But remember, equipment and tools can fail, a slip can occur, and an attempt to overreach can throw you off balance. It is in these situations, when the hazards that may not be so obvious, that will suddenly trip you up. This is where fall protection can save your life. Avoid becoming complacent about fall protection. If you work for long periods of time without falls or near misses, you may feel so confident that you decide you don't need fall protection. Don't ever assume that you don't need fall protection. A single accident can have life-changing or life-ending consequences. You might be thinking that if you ever fall, you will react fast enough to grab onto something to stop your fall. If you have ever used that theory as your fall protection plan, consider this. In half a second, you will fall 4 feet past that pipe or I-beam you were going to grab. In 1 second, you will have fallen 16 feet, and if your body hasn't already hit the floor below in 1.5 seconds, you will have fallen 36 feet. Do you still think you can react fast enough? Also keep in mind that you may be falling backward or head first, or even sideways. So you need a better plan, and that means fall protection. In all areas where you are working at heights, make sure you have both a primary and a secondary or backup system in place. Let's look at an example of primary and secondary protection as they relate to the vehicles we drive. We drive defensively to avoid accidents. Safe driving is a primary control. Because crashes pose a serious risk, we also need airbags and restraint systems. These features are secondary and back up other efforts in the event we do have a crash. We approach fall hazards the same way. Primary fall protection is a preventive safety measure designed to stop falls from happening. Primary fall protection includes solid footing, balance, handholds during climbing, a stable work surface, and positioning equipment. All these will help to keep you from falling. But we know falls are still possible, so we need another layer of protection. Secondary fall protection will keep you from falling to a lower level if footing, balance, handholds, and other primary means fail. Examples include guardrails, hole covers, safety nets, and fall or travel restraint or arrest systems. These are secondary systems that back up or supplement other efforts at avoiding falls. Remember that it is the secondary system that will prevent exposure to fall hazards or protect you from serious injury should you fall, but the idea is to not fall in the first place. Secondary systems are classified as either passive or active. Guardrails, hole covers, and safety nets are called passive systems because once they are installed and maintained properly, they are in place and ready to keep you from falling or, in the case of a safety net, to catch you and stop your fall. An active fall protection system includes work positioning, fall restraint, and fall arrest. The term active implies that workers must take an active role to benefit from these systems. For instance, to use these systems, workers must wear some form of a body harness and tether, or make connection to a lifeline, track, or other anchored connection. These systems only work when they are used and installed properly, and that means by you. Just wearing fall protection equipment will not protect you. You need to rig it and connect it correctly. Since guardrails are the most commonly used secondary fall protection system, we will start with them. Guardrails can be constructed of wood, pipe, or wire rope, or may be a manufactured system using a combination of these materials. If your work places you near a guardrail, take a look at it and make sure it is installed correctly, and that all the rails are solid and not loose. When inspecting a guardrail, the top rail needs to be between 39 to 45 inches above the walking surface, just above the waist of most workers. The mid rail needs to be halfway between the walking surface and the top rail. This requirement is the same no matter what material is used to make the guardrail. Guardrails should be able to support at least 200 pounds of force applied to the top rail without failing or deflecting below the minimum acceptable height of 39 inches. And always look to see if the toe board has a lip or some other type of protection to prevent tools and other objects from falling over the edge on someone working below. Guarding holes and small openings in floors and elevated work platforms is very important. Here are some things that can be done to guard yourself against these hazards. Holes and small openings in floors and elevated platforms must be covered with material that will support twice the weight that can potentially be placed on them. All hole covers need to be secured so they can't be moved by workers in the area or by weather conditions, such as wind. A hole cover also needs to be marked with the word hole or cover to identify it as such. Remember that a cover made of plywood and designed for a worker's weight will not support material carts, scissor lifts, or other types of material handling equipment. If hole covers are located on working surfaces where lifts or other equipment are being used, heavy-duty material is needed so tires don't break through. Regardless, it is a good idea to steer clear of hole covers. It would be better to fix the hole with a permanent solution and prevent a potential trip or fall from occurring in the first place. Guardrails and hole covers that are improperly constructed, loose, missing, or damaged may give the appearance of some level of safety. However, they're a serious hazard. If there are any improperly constructed, loose, missing, or damaged guardrails or hole covers, follow the correct safety procedures and report it. Be aware that in some situations, you may be required to guard or barricade the area until necessary repairs can be made. Whenever possible, using guardrails and floor covers is the best method for preventing falls. There will be times, however, when guardrails and covers will need to be removed or can't be installed due to the work you are performing. For example, when climbing ladders equipped with ladder safety systems. In these situations, you need to use personal fall protection. Personal fall protection might also be the best choice when you need to work hands-free on a ladder. In this situation, you have less primary protection, so secondary fall protection systems may be needed. But keep in mind that even when used properly, a fall stopped by personal fall protection can still injure you. If you are unsure of how to use personal fall protection equipment or how or what to attach it to, ask your supervisor or competent person who is qualified in fall protection. Remember, you use it for your protection. When planning to use personal fall protection, there are a number of important considerations you should think about. The first of these are free fall, clearance, and swing fall. Each is an important part of the well-planned personal fall protection system, and each one should be considered any time you are using personal fall protection. Ask your supervisor or competent person for site-specific information, such as plans for rescue assistance should a fall occur, and the availability of mobile work platforms. Platforms such as scissor lifts and rolling scaffolds can provide a stable work surface and guardrail protection. While platforms may not be suitable for all work at heights, they often provide superior protection from falls. Free fall is the distance traveled, measured from your feet, from the point where you start falling to the point where your fall protection system begins to slow you down, referred to as deceleration. The free fall distance determines the speed of the fall and the potential force exerted on the system. The greater the free fall, the greater the deceleration distance required. It is important to minimize the free fall to as short as possible, and never more than 6 feet. The location of the anchorage and the length of the lanyard will affect free fall. The higher the anchorage and the shorter the lanyard, the better the system. In order to achieve this, always make sure your lanyard snap hook is even with or above the back D-ring of your full body harness. This will result in a 6-foot maximum free fall. It's important to understand any free fall distance of over 6 feet may result in fall forces that your personal fall arrest system is not designed for. Clearance distance is the distance below your working area that is required for your personal fall arrest equipment to activate, decelerate, and then completely stop your fall. This area must be clear of anything that your body could hit before your fall is stopped and includes the distance to the ground or working surface below. Keep in mind that clearance can change if equipment or tools are located directly below your work area, or someone decides it would make a good place to temporarily store materials. Clearance must be calculated in all elevated areas where you might work. This is especially important if you are using a fall protection system that allows your anchor point to move with you, such as a horizontal lifeline. Consider what might happen in a fall if you're using a standard 6-foot, energy-absorbing lanyard that's attached to an anchor point around shoulder level. First, you lose your footing and begin free fall for 6 feet, which is the length of the lanyard. Then the energy-absorbing device on your lanyard deploys for the next 3.5 feet, decelerating the speed of your fall. When calculating the clearance distance required for safety, you must account for those distances, plus your height, or the distance from the harness T-ring to your feet, which we'll estimate as 6 feet, and a safety factor of 3 feet, to account for flex in the system, resulting from the forces involved in the fall. Add all of this together, and at a minimum, you need 18.5 feet of vertical clearance distance between you and anything below you. It is important to always take the time to determine if you have enough clearance for the system you are using. After falling and finding out you didn't have the adequate clearance distance is not the best time to determine your mistake. The final potential hazard you must consider when using personal fall arrest equipment is swing fall. A swing fall can occur when you move away from under your anchor point. When you fall, you will swing back under your anchor point like a pendulum. The result could be your body striking an object or your lanyard being dragged across and cut on a sharp edge. In severe cases, which can occur when using a retractable lifeline, you may hit the ground, depending on the distance of your swing fall. The choices of a personal fall protection system are determined based on your work. There are 3 choices, and each has its own advantages and disadvantages. Work positioning is a system that allows you to work hands-free. Fall restraint is a system that prevents you from falling off an edge or into an opening. This may also be referred to as travel restraint. Fall arrest is a system that catches your body after you have fallen. It does not prevent a fall but minimizes the damage an unprotected fall can have on your body. Each of these fall protection methods uses much of the same equipment, but each has a different use. It is important to use the best method to do your work and to also remember that these systems depend on you. How you apply personal fall protection determines the level of protection provided. Positioning systems are primarily used for work at height, where hands-free operations are required but excessive movement is not necessary. When using positioning systems, free fall must be minimized to 2 feet or less. Make sure you use only short positioning lanyards that are specifically designed for this type of system. Ideally, positioning systems should be backed up with a secondary fall arrest system, since a fall exposure exists when you unhook to climb up or down. Fall or travel restraint systems are designed to eliminate the possibility of you reaching a fall hazard. They must be rigged properly to do so. You should choose a short lanyard and locate anchor points so that your center of gravity, which is your torso or waist, is kept away from the edge. Your hand may still be able to move out over the edge. The benefits of a fall or travel restraint system are obvious. If the possibility of a fall has been eliminated, the potential for serious injury has also been effectively eliminated. When using a fall or travel restraint system, keep in mind that fall exposures may exist to the side of your work area. Make sure your exposure to a fall has been eliminated 360 degrees around you. Using fall arrest is not simply putting on a harness and attaching your lanyard to a structure. If you use a fall arrest system improperly or attach yourself to a structure that won't hold you in a fall, your chances of getting seriously injured are high. As with other fall protection measures, using fall arrest requires that free fall, clearance, and swing fall are taken into consideration before you get into position. Remember that fall arrest should be the last resort for fall protection, and it must be used properly to minimize your risk of injury or death. Whether you are using a positioning system, restraint system, or personal fall arrest system, Each system is composed of the same components, which are body support, connectors, and anchorage point, and if using fall arrest, a self-retracting lifeline (SRL) or shock-absorbing lanyard. Each component must be chosen and used properly in order for the personal fall protection system to work as designed. A full body harness has one purpose: to hold your body in a fall. There are many styles of harnesses and each is different, but no matter what size and style you are using, the harness must be put on your body properly to work right. Select the correct harness for the environment in which you are working. Choose the most resistant and durable harness appropriate for your task and work area. Make sure you inspect your full body harness prior to use. If you are welding or working in areas where chemicals or sharp edges are present, more frequent inspection is needed. Making sure your full body harness is on properly should be your first consideration. The chest strap must be positioned so that it holds the shoulder straps in place and prevents them from slipping off your body should you fall headfirst. If the chest strap cannot be adjusted lower than your collarbone or neck, then you need a different size harness. The leg straps must be snug, but not binding. You can check this by slipping your fingers flat between the strap and your leg. If you can make a fist, the leg straps are too loose. When you can only fit 2 fingers, the leg straps are snug enough. While this may feel uncomfortable, remember that the leg straps will move up when your fall is arrested, and this can cause further injury. The back D-ring should be positioned between your shoulder blades. It can be adjusted with the adjustment buckles usually found on the front shoulder straps. Make sure that the subpelvic straps are not twisted and are located snugly just below the buttocks. If you cannot get the harness to adjust enough for a proper fit, then you may need a different size harness. Connectors are used to connect your full body harness to an anchor point. There are many options available. The most common connector is the energy-absorbing lanyard. These come in a variety of styles depending on your need. Other connectors include snap hooks and carabiners that are used for anchorage to beams and pipes. These must be installed properly, so review the manufacturer's instructions before using. Make sure you inspect each connector before you use it and then periodically throughout the day. The forces that can be generated in a fall are one of the greatest dangers when using personal fall arrest. These forces, if not controlled, can cause severe injury. It is important to consider fall forces when you are selecting a lanyard. Factors that determine fall force include the weight of the worker, the free fall distance, and the deceleration distance. When an energy-absorbing lanyard is used, the deceleration distance is increased. The result is a reduced impact force. The amount of impact force that the human body can tolerate before severe injury has been determined to be 2,700 pounds, which is based on several scientific studies. Impact forces must remain below 1,800 pounds for workers. You don't have to understand all the math for calculating fall force, but you should note that falling just 5.9 inches, while wearing the wrong type of lanyard can generate enough force to injure the wearer. You should also notice that wearing an energy-absorbing lanyard can reduce the force of a fall enough to prevent you from being injured. These numbers prove that the only lanyard you should use for fall arrest is one that has an energy absorber built into it. Energy-absorbing lanyards, sometimes called shock-absorbing lanyards, soften the force on your body in a fall by having up to an additional 3.5 feet of material that flexes or stretches. This means that your 6-foot lanyard will be 9.5 feet long after a fall, an important consideration when determining clearance distance. Double-leg lanyards are used when you must unhook one lanyard to move around an obstruction. The second lanyard is hooked up before you unhook the first, which allows for 100% tie-off. Choose the right lanyard for the job. All lanyards, except those used for positioning work, are attached to the back D-ring of your full body harness. When attaching a shock-absorbing lanyard to the D-ring of your harness, the shock absorber is placed closest to the D-ring. Always review the specifications and manufacturer's instructions to verify the type and position of the lanyard. The final piece of your personal fall protection system is the anchor point. This is the point to which you will attach your anchorage connector. Finding a good anchor point is important because it must hold all the forces you generate when you fall. Anchor points need to be capable of withstanding a 5,000-pound load. Think of it as hooking up a pickup truck to the structure that you intend to tie off to. Look for big, solid structures like I-beams and concrete columns. Also, always attach anchorage connectors as high as possible, at least at the D-ring level, because this will minimize free fall and lower the fall clearance required, as well as lessen the fall force. It is important to remember that at no time should you attach your fall protection equipment to a guardrail. Guardrails are only required to withstand a 200-pound force, and not the forces generated in a fall. A qualified person should determine anchor points below the 5,000-pound load. If you are unsure whether you are choosing a good anchor point, ask your supervisor or other qualified person. Remember that welds can break, bolts can loosen and come apart, and what looks strong can fail. Don't bet your life on an anchor point that won't hold. Always refer to your company policies about use of fall protection when using portable ladders and elevated work around railings. The worker in this image has recognized the possibility of falling over the guardrail while working from a ladder, but his protection could be improved. First, the ladder should be taller, which will provide more stability. He could also work from a platform with a guardrail. Second, he would be better protected if he used a shock-absorbing lanyard. And third, although he is tied off, the location of his anchorage connection below him creates a severe freefall hazard. It would be better to locate the anchorage connection above him, which would decrease the freefall distance, impact forces, and total fall clearance required. Now that you understand you need an anchor that can hold 5,000 pounds, you must select an appropriate anchorage connector that is safe and compatible with your fall arrest system. Although there are thousands of connectors ranging from concrete and steel to wood, we will discuss 3 of the most popular. Tie-off adapters are the most versatile anchorage connector. They can be manufactured in any length and are designed to be choked around the anchor with the wear pad toward the anchor. Another common anchorage connector is the beam clamp. There are 2 types. A fixed beam clamp can be installed on a vertical or horizontal beam and will be secured with a set screw. A gliding beam clamp is designed for use on horizontal beams only, and moves as the worker moves, providing more flexibility. It is important when you are using a gliding beam clamp to make sure the ends of the beams are capped so the clamp can't come off. For a more permanent solution, use a weld-on, bolt-on D-ring. There are mild steel and stainless steel versions. Historically, lanyards have been the main system used to attach a worker's harness to an anchor, but as we have learned, a great deal of clearance is required under a worker who is using a lanyard. When you need to avoid nearby lower-level obstructions, one of the best fall arrest systems is a self-retracting lifeline, or SRL. There are many different types. Some SRLs are mounted overhead. Some mount directly to the back D-ring of your harness. Harness-mounted versions may be referred to as a self-retracting device, or SRD, or self-retracting lifeline with a designation of P or SRLP, which stands for personal safety. SRLs reduce the actual clearance needed to a maximum of 4.5 feet from your feet. This doesn't include any safety factors. A retractable lifeline is also designed to allow you more freedom of movement than a lanyard. As the name implies, an SRL retracts and stays out of your way while you work as opposed to a standard shock-absorbing lanyard, which can get in the way or even get tangled in the event of a fall. The material used in the retractable lifeline may be a synthetic strap or wire rope, and is protected within the SRL. The material is wrapped around a spring-loaded drum that unwinds the line when you walk away from it and retracts the line back in when you walk toward it. In the event of a fall, the device will quickly lock and prevent the lifeline from paying out, which stops the fall. Since the SRL begins stopping the fall within a couple of feet, the chances that you will be able to climb back onto the elevated structure are much higher. Overhead-mounted units should be anchored above you to prevent any free fall. If placed lower than the D-ring, for example at your feet, free fall forces may break the mechanisms designed to stop your fall. You may also be injured by the abrupt action of these units. All types of SRLs must be inspected prior to use. Test that the line unwinds smoothly and retracts back into the housing, then pull sharply on the lanyard to make sure it locks off. Vertical lifelines are commonly used on suspended scaffolds or when climbing ladders. They are typically constructed of rope that is designed to be used for fall arrest. The rope may be nylon, polyester, or wire, and may require extra clearance due to lifeline stretch. Each worker who uses a vertical lifeline will use a rope grab device. The rope grab clamps onto the rope and will stop the fall. It is important that you look at the rope grab to determine if it will work on the size and type of material the vertical lifeline is made of. Rope grabs will be either manual or automatic. Manual rope grabs remain locked on the lifeline until the user disengages the locking mechanism with their hand. Automatic rope grabs will travel up and down the lifeline and only lock off when they descend too fast, such as in a fall. Automatic rope grabs are useful when climbing and when hands-free operation is required, since they travel up and down the lifeline with the person using it. Keep in mind that if using an automatic rope grab, your lanyard needs to be no longer than 3 feet. This will keep free fall to 6 feet or less. Also, when using either type of rope grab, place the rope grab as high as possible once you have reached your work area to minimize free fall. As with any other piece of fall protection equipment, make sure you inspect rope grabs and lifelines before you use them. Horizontal lifelines are also a common fall arrest system on work sites. They are required to be designed and installed under the supervision of a qualified person. Horizontal lifelines usually consist of special stanchions, wire rope, and energy-absorbing components. When using horizontal lifelines, stay connected at all times. It may be necessary to use a double-leg lanyard so you can remain tied off when moving around stanchions. Never attempt to tighten, remove, install, or modify a horizontal lifeline unless instructed by your supervisor. Like any other tool used for work, inspect each piece of your personal fall protection equipment before you use it. Chances are you will be the only person who will inspect it. Your company should have an inspection program in place where a competent person also inspects all fall protection equipment at least once a year. If any equipment is ever involved in a fall, even if it does not show signs of damage, remove it from use, return it to your supervisor or competent person, and retrieve another fall protection device. Competent persons will determine if equipment can be safely returned to service. Personal fall protection equipment can be classified into 2 categories: software, which indicates it is made of nylon, polyester, or other fiber material, and hardware, which indicates it is made of metal. Always inspect your full body harness and lanyard prior to use. The extra time you take could save your life. Equipment such as lanyards, harnesses, synthetic slings, and ropes are considered software. Software should be inspected for loose, torn, or cut fibers or threads. All labels must be present and fully legible. There should be no burns, discoloration, excess dirt or wear, knots, or other damage. If you notice signs that a lanyard or other fall arrest equipment has been deployed, it should be immediately taken out of service. All metal components, such as snap hooks, carabiners, rope grabs, and cables, as well as metal integral to software, such as buckles and D-rings, are considered hardware. All hardware should be inspected for corrosion, cracks, deformation, burrs, and wear spots. There should be no excessive dirt, paint, or grease present on any metal components. There should be no damaged or missing parts, such as nuts, bolts, or cotter pins. All components should operate smoothly, and all springs should work properly. Work the gate on snap hooks and make sure they close properly. If there is any sign of damage or an unsafe condition, the equipment should be immediately taken out of service and returned to your supervisor or competent person. Like any tool, personal fall protection equipment needs to be properly cared for. This is especially true when not in use and being stored. When storing your personal fall protection equipment, never throw it into a storage box or the bed of a truck. It is best to store your equipment by hanging it up, out of water and dirt and away from bright direct sunlight. This will allow wet equipment to dry and will keep it clean and undamaged. The final component in a fall protection program is a rescue plan. If personal fall protection and arrest systems are used, it is important that the proper measures and planning are part of your fall protection program. Imagine that the fall protection system has saved an employee's life. Now, it is time to retrieve that employee safely without exposing rescuers to hazards as well. Rescue must be simple and safe, using ladders, lifts, and engineered rescue systems that meet your company's policies and federal governance, such as OSHA. There is a recommended hierarchy of rescue efforts that should begin after a fall. First, attempts self-rescue. Climb or pull yourself to safety. Second is assisted self-rescue. This includes using suspension trauma safety straps, which, in combination with a full body harness, help prevent the effects of suspension trauma after a fall. Also, a coworker could supply a ladder. The third option is mechanically aided rescue. If self-rescue attempts have not worked, a rescuer can use a lift. And the fourth option, used only in very rare situations, is a rescue pickoff, where one or more rescuers attempt to reach someone who has fallen and guide them to safety. Workers who fall while using fall arrest systems can suffer life-threatening fall suspension trauma within 15 minutes. Quick responses are possible if sites pre-plan for emergencies and have necessary equipment staged where overhead work is performed. As stated at the beginning of this course, working at heights demands skill, focus, and experience. This training is about protecting lives, preventing life-altering injuries, and making sure every employee goes home safe at the end of the day. By using proper fall protection every time, you help build a strong safety culture, one that recognizes accidents can happen to anyone and proves that your safety always comes first. There are many situations that can happen at a job site, but a fall should not be one of them. You should now be able to identify common fall hazards, recall what to do if you encounter unsafe conditions, recognize the types of equipment and methods that provide fall protection, identify the components of a personal fall protection system, recognize the importance of inspecting fall protection equipment, and recall important information about fall rescue plans. Now, let's check your knowledge about the concepts presented in this training.